So recording. Good, attendees are coming in, which is great. So welcome everyone. If you're all here for the 3-minute thesis competition, you're in the right Zoom room or meeting or webinar, as the case may be. We'll wait a few minutes for people to roll in and begin when the attendees start to level off a little bit. What's available to the attendees, Erin, is that they're able to do Q&A or chat. I lost track of that.
Yeah, so attendees are able to click the Q&A button that should be below the gallery window or below the slide share window, and they can type any questions that they have there. But please be aware that you won't be able to address questions directly to the presenters themselves. But we might be thinking about those questions for discussion after all of the presentations have been streamed out.
Good, yeah, that's great. Okay, thanks. Well, good. It's accelerating. Nice to see that there are quite a number of attendees already. Actually, yeah, 16. What number should we wait for before we begin? What do you suggest? Okay, we'll Erin suggested starting at 12:05. Sounds good. So we'll start at 12:05. Well, I might as well start sharing the screen and in preparation for the event. Well, it's 12:05. Welcome everyone to the 2021 3-minute thesis virtual competition. I'm John Bandler, and I have 3 co-organizers, co-chair Erin, and members of the 3-minute thesis committee, Daniel Tajik and Aline. This is us, and you'll see us as the event unfolds. I have a lot of people to acknowledge here, including the steering committees of IMS, RFIC, and ARVTEG, and then a whole bunch of names there, some of whom are at McMaster University, others are associated with the MTT Society, and some of them have been 3-minute thesis contestants before that have stayed on with me and helped out in workshops and various other events. So first of all, let's introduce Sherry Hess, the Master of Ceremonies. This is actually Sherry's third time being involved in this capacity. I think she loves the 3-minute thesis competition. So Sherry, would you like to say a few words?
Most definitely. So hello, Sherry Hess. And as John said, this is my third year being the Master of Ceremonies for the 3MT. My first time I was fortunate, it was live in Boston, and now I'm back for my second year virtual. If you've been on here before, you've heard me say this is one of my most favorite events at IMS. Just to introduce myself, I'm currently the Product Marketing Group Director within Cadence for the company's what we call systems analysis technologies, and this includes electromagnetic, thermal, RF, as well as signal and power integrity analysis for both high speed and high frequency chips, packages, and boards. In addition to my day job, I'm an active member of the IEEE MTTS Society, serving right now on the administrative committee as an elected officer. I also chair the Women in Microwaves Committee, as well as vice chair of both the Meeting and Symposium and Marketing Communications Committee. Many years ago now, I obtained my Bachelor's of Science in Electrical Engineering, as well as a Master of Science degree from Carnegie Mellon University. And I am very much looking forward to being inspired by our presenters today and getting a sneak peek at the technologies and innovations that will be shaping our industry in the very near future. So good luck to everyone.
Thanks, Sherry. That's great. Thank you very much. So our agenda, as I say, is to welcome everyone and introduce the competition and give you a snapshot of the Queensland rules. The 3-minute thesis originated at the University of Queensland. We'll introduce our judges and eventually roll out 23 presentation videos that were recorded live. And then while the judges confer offline, Aline, Dan, and myself will have a panel type session, conversation about 3-minute thesis and related matters. And then when the judges and Sherry, our MC, come back, our winners will be announced on this Zoom call at the end of the event. So Erin, would you like to take over and tell us a little bit about the 3-minute thesis for IMS?
Sure. So as we adapted the rules of the 3-minute thesis for the International Microwave Symposium, we decided to open it up to not only students, but to young professional members who are within 10 years of having received their first professional degree. We decided to open it up to anyone whose technical paper was accepted by the TPRC of IMS, of RFIC, or of ARFTAG for presentation in the technical sessions of the conference. You had to check a little box identifying yourself as a 3MT candidate upon submission of your paper, and you had to be recommended by both your respective TPRC and by the 3MT committee. So Aline, Dan, John, and me. Next slide. So we've been doing this 3-minute thesis competition at IMS since 2017. Last year, we opened it up to ARFTAG and RFIC competitors as well. And for the last 2 years, this competition has been a strictly virtual one. We're hoping to have a live in-person event next year at all of Microwave Week again, so not only an IMS event for all of Microwave Week. So the rules are simple. It's kind of right in the name. Your presentation has to be under 3 minutes long, and it's an oral presentation with one static PowerPoint slide that's going to be visible next to your face for the whole duration of your presentation. And that's pretty much it. but it's difficult within those 3 minutes to present years of complex technical research to a general audience, to kindle excitement and curiosity among that audience, and to make them want to hear more about your research, not less. So we're working with our finalists, our young professionals and students, who will, in doing this, gain research communication skills and an ability to engage non-specialists, an opportunity to share their work, and who are eligible for cash prizes. But this competition also benefits our society. It kind of gives us this cohort of young, enthusiastic ambassadors to bring ideas from the microwave community to the general public. We're hoping that this will stimulate interest in microwaves among the general public and get them to realize that you can use them for more than microwave popcorn, and thereby maybe attracting students and especially young women to the Microwave Theory and Technique Society. Ultimately, we're hoping to improve Microwave Week by putting more people out there who have awareness and empathy with their audience, who are creative and think creatively about presenting their work, not just to other specialists. Of course, the cash prizes. So we'll be awarding 4 cash prizes today, first, second, and third place, and there will also be an audience choice winner. So please watch for a Google poll at the end of the streaming, and we will send the link here in the chat.
And we'll be announcing the winners, as we mentioned, right here today, and they will also be mentioned at the IMS closing session on Thursday, 15:30. So mark your calendars for that as well. So, yeah. So, Erin, would you like to continue with the criteria?
Sure. So now we get to the judging criteria. So we will be introduced to our panel of 5 non-specialist judges. And the 2 broad categories that they're looking at in these presentations are comprehension and content. So how comprehensible can you make the content of your research? And then the engagement and communication. So how well have you engaged the judges by communicating that research? So these are very broad criteria, and the judges have been instructed to interpret them however they like. So it's absolutely intentional that we have non-engineer judges. This is a feature and not a bug. And so some of the more specific rules, I think John's trying to usher me along, that they're being asked to adhere to, is the presenters are not allowed to use any additional electronic media, just their single slide. Again, they can't go over 3 minutes. They need to be spoken word only, no making up songs about your research or doing interpretive dances, though we would like to see that outside of 3MT. And the adjudicating panel's decision is final. So the decision the judges come to is the decision that the judges come to.
So now we come over to, thanks, Erin. Yeah, so now we're ready to introduce the judges for our virtual competition. Here they are, 5 of them. Sarah actually for the 3rd time, Rachel for the 2nd time, Ron for the 2nd time, Amy for the 2nd time, and Elizabeth for the 1st time. So our first judge, Sarah Hartman-Caverly. Sarah, would you like to say a few words?
Sure, thanks, John and Erin. Hello, everyone. It's a pleasure to be with you again, as John said, for my third 3-minute thesis competition. I first judged a 3MT at IMS 2018 when it was in Philadelphia. I tried to participate in judging last year, but if you'll recall, there was a hurricane that passed through my region. I'm in the southeastern Pennsylvania region, and so I actually lost power for quite a few days and was separated from the competition. And I am back this year, and the weather is beautiful, so I should be with you for the full remainder of the session.
Yeah.
A librarian at a regional campus of Penn State University, Penn State Berks. So if I just shift to the side here, you'll see the Nittany Lion Shrine outside of my normal building, Toon Library. And at Penn State Berks, I work with engineering students as well as business and computing science students. And one of my favorite things to do with engineering students is actually patent searching. So if you're interested in the potential patentability or commercialization of your research, I'll put in a shameless plug to talk to your librarian. Lastly, I'll just mention that if my last name Caverly looks familiar, that's because my father-in-law is Dr. Robert Caverly, the editor-in-chief of Microwave Magazine and one of the sort of organizers and steering committee members for IMS, who recruited me originally back in 2018 to judge the competition. So best wishes to everyone, and I really look forward to hearing your ideas and bringing them back to my campus for discussion with students and faculty.
Thanks, Sarah. It's wonderful to have you back again, and let's hope for no hurricanes. Although isn't there a storm heading your way? Or anyway,
there might be a minor disturbance, but I'm going to try.
Minor disturbance, right? Thanks, Sarah. So Rachel Ho from McMaster University. We go back a number of years in terms of 3-minute thesis. She did one at McMaster quite a number of years ago. And she's also been judging 3-minute theses competitions for a couple of years now. So Rachel, do you want to come on and say a few words?
Thanks, John. I'm Rachel Ho. I'm a PhD student at McMaster, as John said, and I look at children with concussion using fMRI machines. And I really enjoyed learning about microwaves last year at this 3MT, and I'm so excited to be back and to learn a little bit more. So really looking forward to it.
Thanks, Rachel. Nice to see you. Okay, and our next judge is Amy Hubbard, professor and chair in the University of Hawaii at Manoa's Department of Communicology. We first met in Hawaii, actually, at the very first 3-minute thesis competition in 2017. So welcome, Amy, and would you like to say a few words?
Hi, everyone. I'm really happy to be here as well, judging. And I think one of the things that really excites me about the competition, at least from a personal standpoint, is that I get to learn all this new cutting edge information very efficiently and quickly and in an easily digestible fashion. And I think what also excites me is that I get to see how people are able to engage in perspective taking, because in order to be an effective speaker, especially in 3 minutes or less, you really need to think about how other people think. And it's really a pleasure to see that in action too. So I'm very excited to be here. Can't wait to hear all the speeches.
Thanks, Amy. Really nice to have you here. Thanks again. And Elizabeth, my friend Elizabeth Indianos from Florida. She's here for the first time. We first met many years ago at a screenwriting workshop of Robert McKee's. Anyway, Elizabeth, would you like to come on and say a few words?
Can you hear me?
Yeah, we can see you and hear you, yes.
Well, I'm very excited to be one of the judges. And even though my field is a multidisciplinary one with music and writing and art and film and all that kind of stuff, I just instinctively always feel a kinship with the science end of things. I think it has to do maybe with, they're both systems of thought. One perhaps goes clockwise and the other one goes counterclockwise. So we're going through the same steps, but just in another way of seeing it. I always think about, and I have thought about that movie and that story of John Nash and A Beautiful Mind. In reading some of his statements and some of the statements of his colleagues, they say that he didn't think like the rest of us. He thought more like an artist. And so the way he arrived at his conclusions and thoughts and research did this vast leap of intuition, which I really relate to. So I'm excited to hear these elevator pitches, one might say in Hollywood terms, but I'm excited to hear these theses. They look wonderful, the titles and all, and this will be the highlight of my day. Thank you for the invitation.
Nice to see you, Elizabeth. Welcome. And finally, Ron McCurdy, who was with us a year ago, professor of music. Ron, would you like to say a few words?
Yes, thank you, John, for having me back. I had such a wonderful time last year, so I'm honored to have a chance to serve once again. I'm professor of music, as John said, at the University of Southern California in the Thornton School. I teach courses in jazz pedagogy, entrepreneurship, which is why I think this is such a wonderful connection for me to have a chance to be a part of this event. In my entrepreneurship class, I'm often telling students to really think outside the box, create things that haven't been done before. Try to find your own creative voice. I should also say that at the University of Southern California, quite a few of our engineering majors also have a love for music. There's a very strong correlation between the sciences and engineering and the artistic world. So, so in some ways, I certainly feel connected to what you all are doing, even though I don't understand most of it. And so the criteria that we've been asked to adjudicate you on are things that I am quite familiar with. So anyway, thank you all. Happy Father's Day to all of those of you who may be fathers. John, I suspect you might be a father.
Yeah. Thank you so much, Ron. That's great. Happy Father's Day to everybody too.
So anyway, thank you so much for having me. I look forward to hearing all of you all's pitches. So thank you again for having me.
Yeah, thanks, Ron. Much appreciated. So a little note to the judges. The judges were actually briefed a few days ago, so we read this statement out to the judges and explained what it is. You know, this is really an unprecedented format, this pandemic that we're living in, this situation that we're living in. And I think as you see the videos, we really want you to excuse any technical issues, any background issues that the contestants had. They really did their very best using the technical resources at their disposal. We worked with them over a number of weeks, and we spoke about backdrops and technical issues like microphones and cameras and so on. So we really did try to get them to do their best. But as I say, there are all kinds of problems with physical limitations and surprises. Now, the videos that you're going to be seeing were recorded live in 15-minute sessions where each candidate had 2 chances at a recording. So there were 2 recordings made in a 15-minute slot, and one of these 2 was selected. And the only processing that was done to the video was cutting off the ends. So so that was the only processing that was done. So don't penalize them for issues related to bandwidth, to camera resolution, and various technical limitations. Now you might ask, why didn't we do this as a video contest where the candidates could submit professionally looking videos? Well, the whole idea of 3-minute thesis is the liveness of the event. And so this was the kind of a compromise that we were facing given the pandemic situation that we're in. So what you will see as the videos unfold is you will see a slide that comes up that's the title of the presentation, the contestant's name and affiliation. Then you will see the contestant's video and slide side by side in a template that was used, the same template for everybody. And that is followed by credit at the end in the video. So you will also notice between the videos, there is a 30-second countdown timer, and it's doing that right now as we are looking at the screen. You can see that green bar slowly shrink. That's 30 seconds. Those 30 seconds give the judges time to make notes about what they've just seen, and hopefully sufficient time. And the whole process is going to be automated, as you will see. So after the 23 videos, which will follow it almost immediately, while the judges are offline deliberating, the judges, the MC and Erin will go offline. Aline, Dan, and I will have a kind of a workshop panel session and discussion that hopefully the participants and attendees can join in. So with that, all video cameras should be off, all microphones should be on mute, and we will let the show begin. So I will now get the playlist going. So bear with me for a moment. You should be able to see the countdown timer here. Now you should be able to see this on full screen. I'm going to turn myself off momentarily and get this thing going. So the timer is now going and the first video will follow immediately. I'm turning off my camera and I'm muting myself. Enjoy, everybody. It's a great competition. Some great videos are coming up.
Is it possible to invent a Harry Potter's invisibility cloak? Perhaps for real life, the answer is no. Well, for microwaves, the answer is yes. Recently, researchers created a magical sheet that if we cover an object, say an apple, with this magical sheet, the apple we covered will be invisible for microwaves. The difficulty is how to design this magical sheet. The answer is simulation. By working with simulations through computers, designers can test their proposed designs with different design layouts, and then they can choose a design that meets their needs. With the help of simulation, they can achieve their desirable design with the least time consumption and without practical tests. Well, the simulation of this magical sheet is still not easy, as it includes too many extremely small structures. My name is Qiming Zhao. I invented a new simulation method to design this magical sheet. We can consider a normal simulation as taking a video, just like what you are seeing me for now. And the simulation includes this magical sheet is like, in addition to what you are seeing, you want to tell the details of my hair movements at the same time. Perhaps we can realize this by using a super high resolution camera, which supports small pixels. Well, it will generate a super large file, let alone the price needed for this luxury camera. With my method, I can introduce adaptive pixels mathematically. I can use small pixels to capture the details of my hair. And I can use large pixels for my background. And I can introduce progressively growing pixels for my body. This avoids of using homogeneous small pixels and thus saves memories and money needed for this video and also for my simulation. Now, I'm working on the next step, introducing adaptive framers to capture the dynamic movement of my hair to achieve a more vivid simulation. That is about my research. I invented a new simulation method to design an invisibility cloak for microwaves in a much more saving and efficient way. Do you still believe that in the future we can have a real-life invisibility cloak? Well, it may still be far away, but I am making it closer. Thank you.
So the craziest thing happened to me the other day. I'm walking my dog in our neighborhood, and all of a sudden I hear sirens, and then we see police, fire truck, ambulances all racing down my street. And my dog starts barking and howling, and I can't get him to stop. So out of curiosity, I start walking towards all this commotion. And as we approach, I see lights flashing, and I hear some people screaming in the distance. And as I turn the corner, you wouldn't believe what I saw. Don't you just hate when that happens? Hang time, buffering, loading. It's a common problem that plagues all mobile users. And with the advent of 5G, these issues were promised to be alleviated. Now, we still have the potential to make that happen. Inside these cell towers are tiny switches, sending our phones and tablets the latest Netflix series, sending ones and zeros at nanosecond speeds, just like a hummingbird's racing heart. But if it skips a beat or pumps too much into another person's direction, just like that one coworker who's always streaming at work, then you're left waiting, even just to send a simple message. Now, there's a new type of switch that beats as fast as light, literally. This new switch integrates with lasers. Yes, the same type that you use to tease your cats with. With the ability to handle higher powers, these cell towers can become fewer, decluttering our view of the landscape around us, and provide no dead spots, allowing you to seamlessly figure out what I was going to say in my intro. Unfortunately, until that day, I'm sorry to say that you'll be left in the dark.
Hello, my name is Ajibayo Adeyeye. I am from the Georgia Institute of Technology, and I'm going to take you back in time. Let's rewind to the 70s where Star Wars, tube socks, and roller skates were all the rage. In addition to these pop culture staples, the very first video game Pong was invented and released. A game similar to tennis, it involves a single white dot bouncing back and forth between two lines controlled by player 1 and player 2. Now, I don't bring this up to give a history lesson, but much like Pong, wireless communication can be considered a game between two players. I think about this every time I pick up the phone to call my parents, all the way back in Nigeria. My cell phone, player 1 in this case, is able to ping my voice to their cell phone, player 2, which is able to respond with their voice, and we can have a conversation. However, like many developing nations of the world, wireless connection can be a bit spotty or unreliable due to the poor cell service. I consider myself lucky to be able to reach my family most of the time, but there are many remote areas of the country where this wouldn't be possible. In my research, I propose a solution to this problem. I have developed a device capable of boosting the cell signal level by over 1,000-fold. Imagine a tennis player with a very strong serve. This means that wireless communication can occur at much greater distances and remote communities can be served. My device acts as an intermediary between player 1 and player 2. So instead of the direct back and forth, as in Pong, player 1 pings to my device, which boosts the cell signal level and pings to player 2. My device is able to achieve all of this while consuming over 1,000 times less power than similar technology. This means that no batteries are needed, and it can be powered sustainably, using solar panels, for example. This is great for the environment and also presents an ideal solution for communities which not much access to power. Now that sounds like an offer you can't refuse. So much like Pong in the 70s, you can say that my technology is a game changer. It is my hope that it becomes as ubiquitous as Star Wars, or maybe even tube socks. Thank you.
Have you ever noticed that when conversations get intense, we people say things like, hey, be cool, or you need to chill? Why would that be? Why would we always refer to lower temperatures? Hi, my name is Paula from the University of Aachen in Germany, and I'm here to tell you what happens when communications heat up. We need electronic circuits and devices in order to communicate, and they, just like us, behave better at lower temperatures. So imagine you take your cell phone and put it inside your oven, maximum temperature. It wouldn't work, right? Moreover, once cooled down again, no way you can save it. It'll be burnt. And that's because conventional circuits do not work or do not stand high temperatures. But what happens then if we want to explore the inside of a volcano or see what's going on inside the engine of an autonomous car? It's hot in there. Or even better, what about outer space? What if we want to explore the surface of Venus that has a temperature close to the barbecue? We need circuits to work there. And you could say, sure, then just take your chip, put air conditioning into it, send it to Venus. Well, that's actually the very simplified version of the solution for some ongoing needs. But let's just analyze it. Well, first of all, it's a bit bulky, don't you agree? And second, how much power do you need? Or in other words, how much could that cost? I mean, we all pay the electricity bill every summer, don't we? So you can imagine, quite a lot for sure. But don't worry, because here's where we step in. In my group, we found a recipe. We chose the right materials in the right amounts and combined them in the best manner to design a circuit that generates radio signals and overcomes this bulkiness and high costs. And we've done that by developing the whole production chain in order to finalize it with a chip, smaller than a fingernail, that consumes very little and that enables wireless communications at temperature at least 300 degrees Celsius or 570 Fahrenheit. Exciting, right? I mean, there's still a long run to go, work to add, parts to add. Yet, we've developed the technology, and that's the key. Because now we know that our work will revolutionize the approach to this problem. Come on, tell me this is not a hot topic. Thanks.
Hello, my name is Renuka. As you can see in the picture, what you see is the layout of my apartment. And I'm giving this talk from my living room. Now, out of the million things that I've noticed during this pandemic, one of thing is I noticed where are there no Wi-Fi or spotty Wi-Fi signals in my apartment. Unfortunately, one such location is in my room. So now that explains why I take all my virtual meetings, including this video, in my living room because I'm close to my Wi-Fi modem. So this is a problem that you, me, and everyone faces in daily life. So what can we do to eliminate this? Before finding the cure, we need to understand what causes this issue. Generally, in your Wi-Fi or in any other wireless networks, we have an input signal of specific input power given to your Wi-Fi network or system. Due to the different tiny components present in your Wi-Fi system, some of the power is lost and the remaining signal is transmitted out to your phone or to your laptops, which is eventually get picked up. Now, what can we do to eliminate or to increase the output signal received by your phone, your laptop, or have no spotty Wi-Fi signals? One solution is you keep increasing your input signal level linearly so that your output power will also keeps increasing. Well, here is the catch. We cannot do this because if you increase your input signal, you eventually cause significant interference with your other wireless networks, such as your Bluetooth or your cellular phone network. So what is the solution? So this is where it gets more interesting and my research comes into picture. Instead of increasing your input signal level for your Wi-Fi networks, I try to minimize the losses in your network itself. So generally, the different components present inside your Wi-Fi network are connected using copper interconnects. We mainly use copper because it's very highly conductive than 99% of the metals that are available. It's cheaper and it's easy manufacturability. But at high frequency region, the conductor copper becomes higher and higher lossy, which causes the reduction in the output signal power that is transmitted from your Wi-Fi network. So what I try to do is I try to study these novel new low loss conductors which can perform better than copper in certain frequency range. Better than copper, I mean not 10%, 20%, but 50% resistance reduction can be achieved with these new novel low loss conductors compared to copper in specific frequency region. And also the advantage of these new conductors are they can also be easily manufactured just like copper and can easily be adopted by the industry standards. Therefore, in my research, I try to use these new novel low loss conductors and say bye-bye to spotty Wi-Fi signals. Thank you.
What if we could control our ears? Imagine being able to choose to listen to only what you want to listen to. Wouldn't that be nice? Suppose you are at a party with your friends and with the loud music in the background, it would be pretty difficult to clearly hear your friends when they try to talk to you. At times like this, it would be useful if your ears can filter out the music and give more priority to your friends' voices. This situation is very similar to what is happening to the wireless devices. Wireless devices can easily be a source of interference with each other. The thing is, this interference can be avoided. My name is Hussein, and I'm from Northeastern University. We are developing a wireless interference limiter. These limiters will allow wireless devices to interact without harming the quality of communications. Wireless devices are just like us. They listen to everything, intentionally or not. However, by using our limiters, wireless devices can choose to listen to signals coming from preferred devices and ignore signals coming from interfering devices. Now, you might wonder, what happens if the preferred device is sending a very weak signal while the interfering devices are sending much stronger signals? Fortunately, our limiters are designed especially for the reception of weak signals. And our limiters have a unique ability to limit the interference even more as it becomes stronger. And you know what? Our limiters are easy to design and easy to manufacture. So no need to worry about your wireless devices interfering. But please, do not hold a party during the pandemic. Thank you.
Do you miss flying? It's been a while, right? But do you miss the airport security screening? You know, the waiting in long lines to get scanned? Not so much. My name is Stavros Vakalis from Michigan State, and today I will talk to you about the airport screening problem. Do we really need all these slow scanning systems? Why not something like a video camera? You know, people just walking, getting scanned, no delays. Let's see first how traditional cameras work. Video cameras that operate using visible light, they can take advantage of the ambient sun illumination or the light inside the room. Airport security scanners use millimeter waves, which are electromagnetic waves like Wi-Fi, and can travel easily through clothing. However, the sun emits almost nothing at millimeter wave, so the airport security scanners need to transmit their own waves and scan all around you, which is slow. Don't we have something like the sun that emits millimeter waves rather than light? Well, we do have the 5th generation or 5G millimeter wave networks where a massive amount of users can communicate with each other. The density of these networks is expected to get so large that the electromagnetic environment will look like a mess. Forgive me for saying that because as an engineer, a mess is not a good thing. However, for my case, this millimeter wave mess will effectively create an illumination, like the sun. My research is about building millimeter wave cameras that can take advantage of the ambient 5G signals. In this way, we can significantly speed up the airport screening process, and we don't send any signal in an already crowded environment. We just capture what's already there, and we do that fast, like a breeze. So next time you fly, just think of your destination and forget about those long lines and the airport security screening. Thank you.
Can machines think like humans? Ask Google Assistant or Siri, but without internet connection. It does not work. Your phone is simply not able to process such huge amount of information without using the internet. Your phone sends the data over the internet to big machines that are operated by Apple or Google. Google massive computational machines process the natural languages by solving complex mathematical equations that require huge computations. The machine then sends the data to your phone on the Google Assistant. If your phone has to do all this processing, it would drain the battery within few minutes. But yet our brains, they have no difficulty in doing such tasks, even complex ones, like vision, like a person waving at you. Your brain does two tasks. First, it recognizes the hand gesture. Second, it takes an action based on that gesture, and you simply wave back. Your brain doesn't require huge amount of battery powers and machines to do so. Now you may think, can we make the machine to work as energy efficient as our brains? I'm Muhammad Arsalan from Infineon Technologies, Germany, and I'm here to answer this question. I have developed a way for a tiny radar chip that can think like a human brain. It can recognize hand gestures just like our brain would. Our brains, they are energy efficient because they process the information through electrical currents called spikes. And my algorithm, it also works the same way. It processes the information through spikes instead of solving complex mathematical equations. You can put this tiny radar chip in any device, in your coffee machine, TV, printer, and many more. And you can control them with your hand gestures, just like science fiction movies. So can we make the machine think like humans? Yes, we can, at least for some applications. Thank you.
Everything vibrates, and vibrations produce sounds. Violin strings, airplanes, bridges all vibrate, contributing to the symphony of the universe. But not all sounds are music, right? Humming, scratching, who cares? Well, we should, because these sounds can save lives. Sounds are used to check the integrity of airplanes and to predict engine failures. Can you imagine of something more important than this when leaving for a trip? Now, our ears capture sounds, but our ears are limited, both in space, as they are confined within our body, and in time, as our attention is discontinuous. Fortunately, we can rely on wireless vibration sensors, our tireless ears. Vibration sensors can listen carefully even to noise, detect anomalies, and transmit the alarm wirelessly in real time. However, commercial sensors cannot be placed everywhere. The sensors are usually battery operated, so they must be available to be recharged. In addition, if temperatures go too high or too low, electronics get into trouble. My name is Valentina Palazzi. I'm from the University of Perugia, and the goal of my research is to make truly autonomous wireless sensors. Sensors which can operate on their own with no external help, even in harsh conditions. How do we do that? First, by developing sensors which need no battery power at all. The sensors are interrogated by wireless signals and simply reflect back the signals. Second, by removing electronics from the sensors. Instead of using devices that must be switched on and off, we print 3D structures which change their shape based on physical variables such as vibrations. These structures interact with wireless signals, modifying them with the sensor information. Not so different from what your ears do. In the end, we just want to simplify technology to simplify our life and make wireless vibration sensors face the storm while we safely listen to Beethoven's Ninth Symphony on our flight. Thank you.
I could not believe that in the last 10 years, we have made more plastic than in the century before that. But only a fraction of the plastic that we produce is recycled. Nowadays, plastic bags can be found in the bottom of the world's deepest ocean. But even here, there's still hope. Today, let's dive in to meet someone. She's a larvation. Yes, the creature in my slides. And our friend larvation is here to teach us a lesson. She filters through her body pieces of microplastics and remove them from the ocean. Wow, I mean, she really recycles. So what if we adopt a good example and apply it in our telecommunication systems? My name is Patricia Bossa from University of Aveiro, and I am developing a system that is just like a larvation. It filters and recycles signals according to input power level and frequency. As we know, our cell phones still depend upon elements that transmit and receives information in a very static way. But what is the problem of static systems? They are fixed, and so they do not adapt to future scenarios. So whenever we consider a new generation of technology, most of our circuits end up needing some replacement. But this means more waste of electronics. And electronic circuits are plastic, metal, and glass. So there is no put it away, this typical phrase, it's not in my backyard. It doesn't make sense. The ocean is everyone's backyard. My new device is a promise to the environment, a solution that can handle 5G and beyond. There is more. This new technology relies on special materials named ferroelectrics. This ferroelectric material reveals its intrinsic behavior of frequency selectivity and power level adaptability. My new circuits can operate regarding different frequency bands and avoid jamming interference that disrupts our communications. My goal is to design smarter and more adaptable circuits to our phones or even to satellites. So next time you think about technology, think about being inspired by nature. For me, I'm living the larvation lifestyle. Thank you.
One plus one times two, equal. Obvious, right? What's the story behind this? Listen to me for 3 minutes. I'm Shagaya from Rutgers University. Look at my window. When you open the window of your room, not only indoor air goes out, but fresh air comes in at the same time. I wanted to build a window, but I'm an electrical engineer. I don't deal with airflow. I work on transmitting and receiving signals. And what's a signal? When you call one of your friends, your voice is a signal. My window can transmit and receive signals simultaneously, but it's not as simple as a real window, because when you have only one device for transmitting a signal and receiving another one, these signals mix with each other and everything goes wrong. So how could I design it? The answer is 1 plus 1 equals 1 times 2. By the combination of two components, one of them from the electronic world and the other one from the electromagnetic world, 1 plus 1. And the result of this combination is a device that can do two functions, transmitting and receiving at the same time, 1 times 2. You may ask, what are these two components? Transistor and metamaterial. Forget all transistor radios. I'm talking about a tiny electronic device which is so functional. It can control the flow of signals. And what's metamaterial? Meta means beyond. It's a Greek word. So metamaterials means beyond naturally occurring materials. Don't confuse. Of course, we use natural materials to design a metamaterial. However, the final engineered structure has interesting properties that are not found in natural materials. So transistor and metamaterial are the building blocks of my structure that can do two functions, transmitting and receiving at the same time. I believe that in engineering, if you can if you can find appropriate materials and the correct way of combining them, you can get an engineered structure that can be used for different purposes simultaneously. So I hope that you don't forget my story behind the title. Thank you.
Hi, do you know how many bones and joints you have in your body? Well, it's 206 bones, but only 78 joints. Each joint connects bones and reduces the friction when you move. Similarly, electronic interconnect plays the important role as electronic joint in communication system. They provide connections and transitions for different signals. Just like joints in your body, electronic interconnect links different parts of a circuit, reducing the friction for fast signal movement. Today, 5G and higher generation application requires this electronic joint to support even faster speed. However, conventional interconnect suffers from larger friction. This causes higher power consumption, unwanted heat, and reduced signal speed. Can you run faster with stiffness? No. My name is Yali Zhang. Let me tell you how we build a better electronic joint, which support faster speed for future communication system. We use bundles of nanowires to form interconnect with less friction. Each wire in this bundle is extremely small, about 1/10,000 diameter of one single human hair. The good thing is these extremely small wires allow high frequency signal to easily penetrate. And by bundling them together, the overall power consumption can be reduced. Now, by using these wires, the electronic joint we build can achieve 100 times faster speed. So in the future, when you are enjoying the faster video streaming or super fast virtual conference, think of this little electronic joint. They're supporting the system just like your knees supporting you to run faster. Thank you.
Hello everyone. We all have heard about the 4G, 5G, and all those G stuff technologies. Well, of course, it's all about the communication speed. The internet that we are getting on our cell phone with 5G is much faster than the 4G. But have you ever thought why these new technologies are faster? You won't believe if I tell you that there is a super small device inside the 5G equipment that makes all the difference. The main block is about 1/10 of a millimeter, and inside this device, there are particles that are called electrons. And the speed of the whole system depends on the speed of these electrons. So everyone in our field is trying to find ways to make these electrons faster and enhance the device performance. But we have noticed that if you keep increasing the speed of the electrons, at some point, the device will not work anymore and you may ruin everything. Like the guy in our picture who turns the tap on, but there's no water flow because he steps on the hose unintentionally. Now imagine what happens if he keeps increasing the water pressure while he has no idea what's going on. This is Sohail Nouri, and my job is to investigate the causes that hinders the device from high-speed functioning. I'm developing a predictive tool in computer to avoid any unwanted surprises in high-speed systems. This tool will help us to know our enemies before we fight them. So, dear electrons, don't worry about stepped feet on hoses.
Hi everybody, my name is Muti Rahman and I'm talk about internet today. So due to the current condition of planet Earth, I don't think I need to stress enough on the importance and utility of internet. It is basically our very important tool that we have used to fight against the pandemic. So internet today is really fast and we are using a lot of good and useful internet applications. But the thing is, the consumption of internet is increasing and the demand for higher data rate is increasing as more and more people and applications are getting connected to the internet infrastructure. In the coming decade, there will be very data hungry and exciting applications that we are going to use. For instance, wireless virtual reality, self-driving cars, and real-time robotic controls. So for these sophisticated applications, we will need internet speeds, which are at least 10 times higher as compared to the current internet infrastructure. So I'm trying to make that faster internet for you. So to make the internet faster, I'm trying to make electrical signals in the circuits go quicker. So the question is how much quicker? So to explain the magnitude of frequencies at which I'm working, I'll quote an example. So we all know Wi-Fi, it's everywhere. So the traditional Wi-Fi, it works at 2.4 gigahertz. I'm trying to target frequencies which are at least 50 times higher than that. Now just imagine what speed we'll get when we'll try to operate our Wi-Fi 50 times faster. Working at such high frequencies is not a trivial thing because there are a lot of challenges. The first challenge is that the material properties are not characterized for such high speed signals. As we move at high frequencies, like strange things happen. So my first goal in this project was to basically characterize the performance of my circuit material for such high speed signals by designing and measuring some test structures. Once that was done, I needed to make some conductive tracks so I can move these high frequency signals from one part to the other part of the signal with a circuit with reasonable losses. So I was able to measure decent performance on the conductive tracks which I designed. So now I have these building blocks which takes my signals from one part to the other part of the signals. I can use them to make other interesting passive electrical components and make faster reality and internet for you guys in coming 10 years. Thank you so much.
Hi, this is Daniel Chan. We're looking at the Spartan Marching Band from Michigan State University. Imagine if they just performed without moving. Boring, right? It is the dynamics that get us excited. The dynamically changing formations. This very same concept of dynamically changing formations is related to my research. In my research, the marching band consists of antennas instead of people. Of course, antennas do not have legs. They cannot move on their own. A possible solution is to mount the antennas on mobilized platform like drones. So, what about the formations? It turns out by increasing the number of unique formations among antennas, we also increase the amount of data that can be collected. An example of how the collected data can be used is to generate photo images like satellite photos. If we permanently fixed each antenna at a specific location, there is only one formation. What that means is a limit on the amount of data that can be collected, which might affect the image's quality, making it not detailed enough. A logical solution is to add more and more antennas. However, this also adds cost and resources. Interestingly, if we deploy a marching band of antennas, we can generate a much more detailed photo. All this without having to add additional antennas because multiple formations are possible through the dynamics. Of course, we want to avoid collecting redundant data, and we also do not have unlimited resources and time. Therefore, the appropriate number of antennas in the marching band, the unique formations that need to be achieved, and the associated transitions are all important topics to be studied. Next time you see a marching band of antenna in the sky, just remember they're dynamically working together to collect more useful data. Thank you.
Imagine you're in a crowded room or a party where you can barely hear the person next to you because multiple conversations are going on at once. My name is Andrea Ashley. The goal of my research was to allow us to remove all of that unwanted noise around you so that you can hear and understand the person speaking next to you but you are also contributing to the conversation at the exact same time without interrupting them. Now, my research isn't really focused on acoustics like the metaphor I just presented. My research is more directly focused towards wireless communication for tiny devices such as your cell phone. Particularly, we focused on microwave frequency ranges, since this is where cell phones or other mobile wearable devices tend to communicate with one another. To solve the problem I presented in the metaphor earlier, we designed, developed, and tested a tiny device. In fact, it's so small, it's smaller than the size of your fingernail. This device allows for wireless communication to simultaneously transmit and receive. And what I mean by this is that it allows your signal of interest to flow in the forward direction, but reject all the noise and all the interference in the reverse direction. As a result, signals can communicate at the exact same time without interfering with one another. On top of the benefits of being so small and preventing any misinformation or errors to be transmitted with your signal, my device also amplifies the signal of interest, similar to how a microphone amplifies a speaker's voice. Essentially, my device allows for a two-way conversation for wireless devices. So next time, when you're at a party and you can barely hear the person talking next to you because there's so much noise, maybe you should consider if it would be nice if you could remove all that noise, hear the person speaking next to you, but also contribute to the conversation at the exact same time using similar techniques I used in my research. Thank you.
The universe is made of matter, 4 states of matter. They are solid, liquid, gas, and plasma. While there are 4 different states, can you believe that 99% of the universe is made of plasma? You may be wondering, why do we need plasma? Or what even exactly is plasma? We all encounter solids, liquids, and gas every single day, whether it's the air we breathe, the water we drink, or the objects we touch. But when going outside of Earth, 99% of the universe is filled with stars, nebulas, and interstellar particles, which are all made of plasma. Doctors and engineers are exploiting it to better humanity's livelihood and exploring the depth of the universe. Hospitals use plasma to treat and disinfect bacteria and viruses on surfaces and even on patients' skin. The glowing plumes at the end of rockets and satellites propelling them into space are also plasma. While the universe has no problem making plasma, here on Earth, humans have a difficult time. The reason is that generating and controlling plasma is like controlling an explosion. You don't know how much energy it's going to need before it's too late. If you give it too little energy, the plasma isn't formed. But if you give it too much, things may get pretty hot and maybe even blow up. My research is to develop electronic circuits that can predict and detect the various states in generating plasma and control the given energy such that it can remain safe and stable for a long time. Our circuits are designed to send small packets of energy to the plasma, then detect the plasma state, and in response adjust the next packet of energy such that the plasma can remain stable. This must all be done very, very quickly, or else the plasma may cause an explosion. However, our circuits carefully control the plasma state and guarantees that these dangerous situations will never happen. So the next time you visit the hospital and you see a plasma disinfection torch, Or if you're watching the next NASA launch that will send man back on the moon and maybe even onto Mars, know that a lot of time, effort, and technology is spent keeping people safe when experiencing 99% of the matter in the universe.
Childhood days, crazy times, just like chasing someone with a blindfold, riding your cycle without using your hand, jumping off the wall, and so on. There's one more thing I bet none of you have ever tried: one hand clapping. Have you ever tried one hand clapping? During my school days, one of my friends challenged me to clap using one hand. I tried many times, but I failed. It was really difficult. Even today, I can't do this. Hi, I am Pratik Kumar Sharma, and I am from Indian Institute of Technology, Guwahati. My thesis motivation is based on one hand clapping. And you might be thinking how it can be possible. Let's see. In today's world, we all are striving for high-speed internet, for movie downloading, for video calls, for live streaming, and so on. Do you know who is going to fulfill all this demand? It's 5G. Yes, you must be hearing this word everywhere in this world. What is 5G all about? It's nothing but it's a next generation wireless standard for your mobile phone. Just like Windows 10 comes after Windows 8. So my thesis is to develop new methods to increase high-speed internet, and that can be used in 5G phones. Do you know how phone works? Just like clap. We all need two hands to make clap. Similarly, our mobile phone requires two signals. One when we are speaking to someone. Other is used when we are listening to someone. So this way we can speak and listen simultaneously at the same time. Now imagine using one hand, your mobile phone also have only one signal to speak as well as listen. And now you are available with two signals. That means you can double your internet speed. That's the main idea of my thesis. In this work, we have developed mobile phones that can work with the same signal. So the next time when you are in a problem and you don't find any solution, just recall your childhood days. If you fail, at least you will be happy. Thank you.
When I say radio, do you feel nostalgic? In fact, radio is any device that can send or receive wireless signals. It is crazy to know how many radios we use every day. Your smartphone will have at least 5 to 6 radios for features like Wi-Fi, Bluetooth, and others. Your smartwatch will have at least 3 to 4 radios, and You can add a few more for your laptop and so on. I am Vijay and I'm here to talk about one particular radio in the smart devices. The radio that receives signals from satellites for navigation. For example, the GPS receiver on your smartphone. Like GPS, there are 5 more navigation systems worldwide, and some of them are available globally, while the remaining are available in a limited region, like India's Navig system. Let's say our radio works just with GPS. That is enough for navigation. However, in certain places, the signals from other navigation systems might be stronger than GPS signal. There, we want our radio to switch to the stronger signal. But these flexible radios consume lots of battery power. So how do we fix this? To work for longer duration with the same amount of battery capacity, we want our radios to be power efficient. And my research focuses on designing of low power radios that works with all the navigation systems. Recently, we have designed a low power radio that works for 4 navigation systems, including Navig and GPS. This radio removes all interfering signals and selects the weak desired signals which are transmitted by faraway satellites, then amplifies these weak signals over 300,000 times while consuming very little power. And my target is to reduce this power consumption further down. By how much? I want to cut it down by 50%. See, I'm very greedy here. Next time, when you go exploring unknown territory, remember that these tiny radios can keep you on track. Thank you.
What if your phone could produce an image of MRI quality? Imagine a world where you could see underneath your skin without having to schedule an appointment weeks in advance. If you didn't have to worry about the harmful x-rays from a CAT scan, how often would you scan yourself? And what would you use the scan data for? Thermoacoustic imaging could make this all a reality. Here's how it works. We send strong yet short pulses of microwave energy into the body. This results in thermal expansion of certain types of tissue. The thermal expansion will generate pressure waves that can be detected by an ultrasound receiver. This results in a high contrast image that can differentiate blood vessels from fatty tissue and tumors from benign glands. Sounds promising, but what's the catch? To make this form of imaging portable and affordable, we need to be able to transmit high amounts of power safely from a small handheld device. My name is Christopher Sutarja, and my research focuses on the development of a high power yet compact microwave transmitter for thermoacoustic imaging. Normally, when the chip tries to transmit this amount of power, this amount of wireless power, it'll either melt or short circuit. Our technology enables this high amount of power to fit in a small USB-sized device. The transmitter is only on 1% of the time. The targeted tissue heats up less than a tiny fraction of a degree. Here's a vision of a future where this type of imaging is everywhere. You can see a finger unlock a cell phone using only the detected pattern of the blood vessels underneath. This form of biometric authentication is far more secure than just a fingerprint alone. We can measure much more than just fingers. Imagine a doctor being able to scan a patient multiple times a year for multiple types of cancer using a portable handheld device. More frequent measurement means higher chance of early detection. Early detection means earlier treatment. Earlier treatment means higher chance of survival. We are only scratching the surface of applications for this type of amazing technology. It is often said that we must look inside ourselves for answers. This technology literally enables you to do just that.
We should all trust science, right? Well, not blindly. A scientist would never do that. Scientists are very picky with words. For instance, I hate when people confuse noise with distortion, because distortion doesn't have to be random. Distortion is broken information. Unlike noise, distortion is only produced when you send a message. And also, scientists only really trust science that they can validate with measurements. I'm Ricardo Figueiredo from Aveiro, and I measure distortion in radio communication. My problem is how to build trust on broken information. You might be wondering, is it even possible to distinguish this distortion from the true message? Well, yes, it is, with silence. Radio frequency silence. Imagine, I have my full speech. What if I remove a part of it and made an abrupt pause? This would be awkward. And just like us, radios fill awkward silences with their distortion, allowing you to measure it apart from signal. But this is not enough to trust broken information, because this only works as long as radios can memorize your message. Otherwise, distortion varies depending on how they remember it, forcing you to measure both distortion and memory. To do this, some have suggested having several moments of silence, assuming that each of these pauses would capture how radios remember specific parts of the message. But I have shown that this is not a good idea, because now, depending on where you pause, for instance, here or here, the way the message is remembered changes. Pauses interfere with each other. It is better to use a single pause and move it along your message every time you send it. This measures each part of the message correctly, accounting for both memory and distortion. By improving these distortion measurements, I am actually building scientific trust and allowing better communication. But please, don't just take my word for it, take some measurements. That is the way scientists trust each other. Thank you.
Would you believe 10% of the world is undernourished? And that 40% of the food produced on farms is wasted. This wastage is due to shortage of resources, pests, or even market conditions. In the coming years, with migration to cities and global warming, this wastage is only going to increase. Now, how do we combat this issue? We need a revolution in agriculture. Our sensors do just that. They act like eyes and ears on the farm to sense various environmental conditions like humidity, temperature, or even check if the crops are ready to be harvested. But sensors consume power, now supplied from batteries. Replacement of batteries is effortful. Our devices are designed at near zero power levels, thereby increasing the battery lifetime by years. Our devices can be mass-produced and can be fitted with a variety of sensors to sense a variety of conditions. For example, our devices can detect the humidity and activate the irrigation system. The same device can sense the temperature and the sunlight levels. All this information can be processed in the device itself and hence automating the system. These devices can communicate with each other over long distances as part of Internet of Things. Our devices are also environmentally robust, so we can use them during all seasons of an year, all without human intervention. My devices are one-time deployable solutions with very low replacement cost. They can be easily scaled and will allow us to monitor the farm conditions remotely anytime. My name is Divya, and our goal is to increase the agricultural production, reduce its wastage, and we can achieve this by deploying the zero power sensors everywhere. Thank you.
Every living being knows light is life. Plants, for example, they need light for photosynthesis. Think about sunflowers. They even learned how to follow the sun during the day. Sunflowers are really like autonomous machines. They tilt their stems during the day, so they always face the sun. My name is Giordano. I'm from University of Perugia, and my team developed the sensor with the same philosophy. It changes its shape according to the environmental conditions, in particular humidity. Humidity is the quantity of water vapor in the air, and it is a challenging parameter because it causes degradation of goods. In fact, humidity is constantly under control in museums to maintain relics in good state of conservation, as well in libraries, where there are plenty of books vulnerable to humidity. This is true also for plants in greenhouses, because the wrong humidity level can damage plants. Now, just as a practical example, imagine having a greenhouse or even several of them. Now you know that you should monitor humidity 24/7, night and day, winter and summer, all year long. To do that, you can buy very cheap electronic sensors already available in the market if you want to automate this monitoring process. But you know, greenhouses are quite harsh environments. No power plugs to power electronic devices, no Wi-Fi signal to communicate with them. Here is where my sensor comes into place. This sensor is fully passive, wireless, chipless, and paper-based. It means that it has no batteries, no wires, it is low cost and made of sustainable materials. Basically, you can use it wherever you want. If you want to know the humidity level, you need to send to the sensor a radio frequency signal, and it will echo back instantly the information about humidity. So, the next time you see a sunflower, remember this sensor that feels humidity like a sunflower senses the sunlight. Thank you.
Hello, everyone. It's all over. Who's online? I only have Daniel visible right now, so the judges and Erin supposed to leave.
So John, hi. Before we do leave into our judging session, what I want to correct is it's not all over. The judges are about to deliberate and choose winners. And while they're doing that, we'd like the audience to also help us choose one of the winners. So audience, if you look in the chat for this Zoom webinar, you'll see a link there to a Google form. This is for the Audience Choice Award. Remember, there's a cash prize given to the Audience Choice winner. So make your choice seriously and earnestly and sincerely. And I am going to leave this call with the judges. We'll return after they finish deliberating in a few minutes, and then we will announce the winners. So do sit tight to hear the winners. In the meanwhile, John and Dan and Aline will lead you through a discussion of the videos that you just saw and of the principles of 3MT in general. So I'm going to be out along with the judges, but we'll see you in a few minutes, guys. Bye.
Yes, thanks, Erin. I look forward to seeing you again. Good luck.
All right, thanks.
Good luck, everybody. So, great. So 15 to 25 minutes or so, a discussion with Aline and Dan, and hopefully get some audience engagement here. First of all, having trouble with this mouse. First of all, let me just introduce Aline. Ron, you're still online. You might want to log into Erin's Zoom call. Okay, great.
Elizabeth as well, I see. She may want to leave this call and then join the one that Erin has linked to you in email.
Right. All the judges should be leaving right now, and Sherry as well. Does it look like they're all going down?
Yep, it looks fine now.
Okay, great, wonderful. Okay, good. So Aline, second place winner and Audience Choice winner from Boston 2019. Aline, are you there? Would you like to say a few words?
Yeah, I am here. First of all, congratulations to everyone. You guys made it here, and you did not only make it here, I'm assuming you learned a lot, and that was very obvious from your videos. So congrats in advance. So I'm a fourth year PhD student at Georgia Tech. As you can see, I do participate in a lot of competitions, and thankfully I've been winning. I do have a bunch of awards, industry speaking awards, design competitions, Best Paper Awards, and I do research on energy harvesting and backscattering communications. And yeah, this year I'm on the committee, and I'm looking forward to talking with you right now and hearing your opinion on this year's 3MT.
Great. Thanks, Aline. We'll be doing quite a bit of talking here. Let me move on. A couple of pictures. Aline getting an award in Boston in 2019, and Erin and myself. There she is again on the stage. And again, unfortunately, we won't have this kind of event. This is the closing session event, but we won't be having it in person this year. There is Aline with her tarantula called Lucy. That's a screenshot from the video that you can find online. Great video. I've used it in workshops to kind of analyze, and we'll talk a little more about that later. And here's Dan, who's been patiently waiting to say a few words, I think. Actually, he's already said a few words, but Dan, say something.
Yeah, I can add to the words I've said already. Just like to echo what Aline has said, well done on the presentations to all the contestants. I really did like all the videos, and I was impressed to see the growth that many of you had from the beginning. I had the opportunity to see you guys sort of start with your presentations, try to find your slides and your scripts, and it really came together. A lot of the metaphors that were used are really incredible. So well done, pat on the back to all of you. In terms of more about who I am, my name is Daniel Tajik. I am also a fourth-year PhD student at McMaster University in Ontario, Canada. And I participated in the first 3-minute thesis competition at the IMS in 2017, and I won the first place and audience choice awards for my presentation there. And yeah, I'm excited to be a part of this. Glad I've been able to sort of watch this sort of grow from the beginning and assist John with the developments of this 3-minute thesis competition. I think it's incredibly valuable to see young professionals start to try and improve their ability to communicate their research clearly. It's something that I know was sort of, I struggled with in terms of being able to go from that very theoretical side, that very sort of high level thinking, to one that is appreciable by any audience. So I really think there's a lot of value in this competition, and I'm glad to see that we got a lot of really nice presentations out of this, and yeah, happy to talk more about the 3MT and this competition as well.
Thanks, Dan. And here he is in Hawaii getting the 2 awards. We didn't have the closing ceremony award. This was a separate occasion. Really incredibly memorable. And here are some of the other winners as well with us. And here he is on stage, a screenshot. And I don't have his blueberry here, but notice the blue tie, notice the color coordination with the 2 logos up there. It's all part of a plot to win, and he did. And as I say, I'll stop sharing slides in a moment. I just want to remind you that the competition winners will be announced here as soon as the judges with Erin and Sherry return. They'll return to this platform, and the winners will be announced. So do stay with us. And also the winners will also be announced at the IMS closing session. And with that, I think I will stop sharing. And that's as I say, I'm just blown over. I've been with these candidates for so many weeks, and I was listening to many of them with different eyes, and listening them with different ears and watching with different eyes. I saw things that I didn't see earlier. It's amazing. I just think they've come an incredible way. The judges are going to have a really difficult time. I don't know how I would select a winner. I think they were all so good.
Yeah, I think I just want to make a quick note here for the Audience Choice Award. I mean, you guys don't vote for yourselves. I am sure there's another video that you liked a lot. So just choose someone else. Okay, don't choose yourself.
Yeah, there's a number of contestants on here, which is nice to see that the participants have grown. And yeah, it's great. To me, this is heart pounding. These are heart pounding moments for me too. Actually, I'm really, really curious. I'm just dying to know, what the judges come up with.
Yeah, I absolutely don't envy their position at all. I wouldn't know. I wouldn't know how to score it. There were a lot of really incredible presentations.
Right.
One of the things I'll also add before I know we're just going to sort of openly chat here. I believe there is a question and answer bar at the bottom of the page. If you guys have any questions that you would like to ask us about the competition itself, or just any questions that come to mind, please feel free to post them there and we can sort of talk about it openly here. And yeah, that can sort of further drive some of the discussion. Or if you would like to, have something to say, join in the conversation. Yeah, just post something there.
And I think the other thing I should also note is that certainly once the judges return with their choices, if any of the finalists are actually online here, they'll be invited to say a few words, following the announcement. So do stay and do be prepared. So I think we can allow attendees to speak, right?
Possibly here.
Yeah,
yes,
yeah.
There's an enable. Yep.
Yeah,
so
there's an enable button, so we can allow people to speak. So, Aline, why don't you tell us about your experiences with 3MT and the incredible, tradition that you have at Georgia Tech in 3MT?
Well, yeah, I am biased here. Go bio. No, it's just that, our lab at Georgia Tech it's famous at the Athena lab, we're famous, to have every year someone at the 3MT, and not only having someone competing, but also people winning. And I don't know why, to be honest. I mean, we're good, but I think we're pretty creative, and we learn from each other as well. So we're always thankful for other people helping us, and for you, John. I personally learned a lot from you. Maybe other people relied on, a colleague in the lab. So yeah, I mean, well, I hope this, this tradition continues. I really need to make sure that people after us keep competing at 3MT.
Yeah, no, good. As I say, you've been an incredible inspiration, Aline, with the workshops that workshops outside the IMS as well. Ones that I've been giving outside the scope of IMS. So be incredibly influential in workshops. As I say, I think there are 2 people from Georgia Tech in this particular competition.
Yeah, I know there is bio. There might be someone else also. Should we allow people to talk, maybe by me more interactive? What do you all think? I'm not sure. Posting anything in the Q&A for now.
Yeah, we can do that in a moment. So Dan, why don't you tell us how 3MT impacted your presentation skills in general? And not just this kind of presentation, but actually technical presentations.
Yeah, sure. So I started my graduate studies in 2015, and up to that point, I don't think I really had very strong presentation skills. I know that one of the first conferences I went to went a little bit awry with my attempt to try and present my research, and so it was a skill I was lacking for sure, and something that you sort of hope to develop through your graduate studies because you're going to be presenting at conferences. But yeah, the 3MT, I think, John, you sort of brought me onto it initially. I believe it was 2016. It was the McMaster-based competition, and I got to see some phenomenal presentations, and I really sort of was inspired by how they were able to clearly explain their research in such a short period of time, and sort of how eloquently they could, especially with very minimalistic slides. Because up to that point, I sort of went into it, and the contestants will know I've iterated on this a couple times, but I sort of just assumed every slide I should create should just be a summary of what I'm saying, right? I just should whatever I'm going to spout out of my mouth, it's going to be on the page behind me. But really, it doesn't really add value, right, to what you're presenting. You're just repeating yourself, and the only real value it has is as a reference later on, right? If you want to look back on the presentation, a couple months or a year or two from now, you can understand what you were saying because it's literally said on the slide itself. But if you want to create a sort of valuable presentation, you have to sort of break those two apart, right? Try to have information on the slide that isn't really text-based, really reduce the amount of text that you show, and really talk about it using the slide as sort of a backup or supportive to whatever your verbal argument is. And I think that was sort of one of the sort of first things that caught my attention with the 3-minute thesis. And then afterwards, I got into the IMS in Hawaii 2017, and that was the first year of the 3MT, and I participated in that as well. And the whole process of preparing for it really completely changed my sort of attack towards creating presentations to begin with. And after that point, I really felt like my ability to present, exponentially improved. I don't know, I can't really put my finger on, all the little things that I sort of learned from it. There were an enormous amount of little things that you sort of get experience with when you go through these presentations. But I have come out of it, and now I have a lot of confidence when I go and execute any typical technical presentation, just because I sort of have an idea of how to create good flow of a presentation and how to keep my slides being supportive of what I'm saying. And there's a number of other smaller aspects we could dive into, but that's sort of my growth. Really, it's sort of all changed for me around 2016.
Well, you put a lot of time into the rehearsal process, Dan, as I
absolutely
recall, a lot of time. And
absolutely.
Then what I did at McMaster University, a few days before we all went to Hawaii, we had a rehearsal, and I brought in 2 winners from McMaster University in totally different fields to watch you. And the first person that came in made a small suggestion. I don't recall what that suggestion was, probably about your slide. I think you made a small adjustment to your slide. And then the next person came in. They were quite independent. They weren't listening to each other. And the second person who came in, who was one of McMaster's winners, when asked to comment, had no comments at all. They were just blown away. And I think the number of hits or viewings of your video probably over 3,000 by now.
There you go.
Yeah.
YouTube famous, I guess.
That's right. Microwave's becoming famous. So I think, if anybody wants to say a few words, now is a good opportunity. Don't be shy. Maybe raise your hand or attract attention somehow, and we can probably allow you to talk. There's a bunch of people there that certainly some of the contestants, if you want to have a chat, ask questions, just draw our attention to this. Now, in terms of this particular competition, just to give an idea to those people who are not contestants, how we did this, we held workshops. There were actually, by my count, 25 workshops that were anything up to 2 hours long. And typically there would be 6 or 7 of the finalists at any one of these meetings. And some of the finalists kept on coming back over and over and over again. And we worked on the title, the script, the slide. And I think the nice thing that I found, and again, Dan and Aline, you can comment on this, what I really like doing, and I kind of stumbled into this a couple of years ago, and that is to get contestants in as a group and going around in turn and asking each of them, whether it's the script or the slide or a rehearsal, and they can watch each other and learn from each other. I thought in the few years ago, particularly when we were doing this together, Aline, in your year, I think we had one-on-one Skype sessions, and not many of the contestants took us up on that. And the reason for the one-on-one, I sort of thought, well, maybe the contestants or finalists don't really want to know what, or they're afraid of what the other contestants might find out. But as I say, I stumbled into it by sheer volume of people that were coming to me that I have to have group sessions. Then I discovered they were actually very helpful. And I think that raised the overall level to the extent that I think the judges will have a hard time today coming to a decision because they're all so good. So Aline, why don't you comment on that?
Yeah, I want to say something here. I actually admire and respect a lot the way you guys contestants dealt with each other's on this call, because I remember at my time, even when you, John, said you're going to do this kind of group meetings, I personally said I don't know if I would have done it the year I was participating. And even I remember in 2019, imagine right before the competition, we were sitting in that room, and then you said, if you guys want to go just, present on stage, it just felt weird for everyone to do it. I remember some people just left the room. They don't want to present their 3MT half an hour before the competition in front of us, because what if you steal something from them? What if you steal a move? It's really difficult to make changes to your 3MT half an hour before the competition. Like, it's not gonna work. So I really respect what you guys did. Like, some people helped each other on calls, and that's really good. And it shows how what kind of attitude you have. It really reflects positivity.
There was, honestly, I encountered no negativity whatsoever. Not a single person said, can I have a private meeting because I'm a little bit reluctant to share my ideas with somebody else. And if you think about it, there were a lot of very similar topics that were being talked. A lot of stuff about two-way communication and interference, and there was a lot of, in a sense, overlap in topic and so on, which is interesting, and yet there was no kind of negativity at all or hesitation. I think was just incredible. I just find that everybody was so willing to help everybody else.
Yeah, I think it's one of those things also. There's this discussion of like a competitive advantage, right? Like, if you get to listen to your other competitor's speech, can you introduce some remark that gives you some edge? But I think doing that is exceptionally challenging and maybe potentially off-putting to some of the judges. And really the value from watching the other presentations is that you can see some of the, as it's being developed, right? Because usually you start in the early stages, you can see the mistakes that other people are doing that you yourself may not realize that you're doing, or you may miss when your presentation is given and is not really resolved during the sort of time of discussion where you're trying to solve those problems. So just the ability to see everyone's presentation and the ability to sort of really catch and visualize some of the errors that other people are making in order to improve your own presentation really leads to this huge value of doing these group sessions. And I think it's sort of, it makes everyone better in the end, watching everyone sort of grow and improve and trying to better each other. You can see things that work, you can see things that don't work, and you try to make your presentation as strong as possible. And so I do appreciate the competitors, being willing and open and allowing that to happen. And I think it made all of your presentations a lot better.
Anyone want to ask any questions at all? You guys are
they're anxiously waiting for
anxiously waiting.
I can't blame them.
Yeah,
I can't blame them.
Wonder what's going on in the judges area there.
Yeah, I think in the meantime, I can share something that I haven't even told John about, which is crazy. You remember, John, I told you that I was planning to participate in the Georgia Tech 3MT this year. And I want to tell this story to everyone, for you guys here to not be discouraged by what the judges will say today. Do not think that your presentations were not good enough. I don't know. I mean, of course, there are always changes to be done. But let me tell you what happened. So I gave at Georgia Tech last year, I think, a workshop on how to communicate better and how to do 3MTs. And I consider myself good at this. And I won two prizes at the biggest conference in our field. And then I said to myself, hey, why don't I participate in the Georgia Tech 3MT? I haven't yet done that. So we pre-record the videos ourselves. It's not the same way John does it. So we send them the video, and then there are several rounds, and then, you know, you pass the first round, you become a finalist. I didn't even pass the first round. So this was, so let me tell you the story. My video was amazing. It was maybe 100 times better than my 3MT IMS video, to be honest, the way I recorded it. I thought to myself, I'm going to win this. I was so confident. And then this is a 3MT of all engineering. It's not only electrical engineering. So it's similar maybe to McMaster. I'm telling you something. In this case, I wouldn't say I did not do a good job. I'm just telling you, it depends on the judges, on the way they think, what they like the most. So, I mean, if you, John, look at the titles of the 3MT, you would flip the table. I'm trying to do something to change Georgia Tech 3MT. I'm sorry to anyone from Georgia Tech here, but it's really bad. It's very bad. The titles are, yeah. So I'm just saying, do not be discouraged. Whatever this is, just know that you have learned something. You will do better in every single presentation from now on. So that's really hard for me to tell because I'm on the committee of the 3MT. I was not even a finalist, but I had to share it because I'm sure it will make you learn something.
Yeah, no, Aline, that's very brave of you to share that. No,
Yeah.
and that's really important. That is important. I've been in this now since 2015, and I've seen some very, very strange decisions that have been made. Quite frankly, odd decisions. So sometimes they make the right decisions, and everything seems to fall into place. And every now and then something seems to go terribly wrong. And again, maybe I should tell something that maybe involved Dan a little bit here. So Dan repeated his 3-minute thesis presentation in our department, and our first department 3-minute thesis, with of course a totally different set of judges. And there was one contestant that I could tell, remember Kanshu Zhang, Dan?
Yeah, of course.
We rehearsed. I think you were actually there in a rehearsal as well.
Yep.
With
that was one of the first group rehearsals, actually.
That's one of the very first group rehearsals where Dan and Kanshu were both in the same competition. And she just got better and better and better. And I remember when she was up there presenting before Dan had, I don't know, had you presented already before she did? I don't remember the order.
I can't remember.
But anyway, whatever it was, when she presented, and she did an incredible job, I looked over at Dan and he looked a little worried. I could see a worried look on his face, but he still won in the department. So
yeah, I actually think she probably deserved to win that one over me.
I know.
She was really exceptional at that.
Yeah, she was good. Kanshu Zhang, you can find her 3 minutes.
It's a YouTube video, yeah.
Yeah, on YouTube. Yeah, so listen, everybody did incredibly well, and there are always some surprises. There are some that you'll say, oh yeah, it's obvious, and sometimes there'll be some surprises, and yeah, so thanks for sharing that, Aline. That's great. Any Q&A for anybody?
No, it's a quiet group today.
It's a quiet, subdued group. Maybe we should do poetry or sing. Anybody?
No one wants to hear me sing. I can promise you that.
Nobody wants to sing.
The room wasn't that quiet in IMS Boston while waiting for the results. That's crazy.
Yeah, I think definitely, hopefully next year it can be one of these in-person 3-minute thesis competitions. That's where they really shine, standing up on stage and giving that presentation to a full room is it's a very unique experience for sure. And so I also recommend those of you who are competing this year and want to potentially try again next year, you should definitely do that.
Absolutely. Yeah, repeat. But again, as with Aline's experience, you can win one year and something may go somehow for reasons that are not clear, not come through. But yeah, I think we reached a kind of a high in Boston when it was standing room only. And I remember when I went into that auditorium, I realized that I had underestimated the number of people that I think the auditorium should have held. I think I had asked for 200, but it turned out we got one with 100 people, and that there were desks, I believe, in there as well, so we couldn't really move things around very much. And people were hanging around the doorways, trying to get in, leaving because they, sad that they couldn't watch the competition.
Mm-hmm.
But the judges actually conferred, if I remember correctly, in the room itself.
That's true.
They were actually in the room, and honestly, I recall you could hear a pin drop. The audience was just mesmerized, waiting for the result.
Someone, John asked a question saying, I noticed that some of the talk were missing, where because they didn't show up in the recording. Would you like to answer?
No. A couple dropped out because they felt that they were not really properly prepared. They worked towards this. And the reason that they're listed as finalists is because, they were chosen as finalists, and there's nothing wrong with them declaring themselves to be finalists. So we kept them on the list that's on the in the program. But at some point they made the decision that they didn't think they were giving this their best shot, or were unable to do it, and that was the reason. Any other questions? But next year, having it in person in Denver, I think definitely we should ask for a room that holds 200. It's very popular. It's so different in person from this.
Yeah, absolutely.
So different.
I can still remember like the getting ready for that competition. I still remember like sitting in the room. It was in Hawaii, and I had a hotel that was 30 minutes away. And I remember I had to walk, and I didn't want to sweat. So I was like trying to like walk all the way there, trying to stay in the shade as much as possible, getting into the room, trying to cool myself down as much as possible. And then, you have this sort of setup. You got to put your microphone on, you do a little check, you hope that nothing goes wrong. And then I still remember when they called my name, I walked up onto the stage and I did a little bit of a trip. And I know that one of the things that, John, you always said is the first impression is everything. While you're sitting in the chair, there's a first impression. While you trip on stage, I can remember hearing that in my head. It's like, yeah, you trip on stage, that's the first impression. And my foot caught one of the wooden planks of the stage, and I did a little jerk, but I don't think it's actually in the video. So at least anyone who watches the video doesn't get that first impression. So yeah, the live experience, that was really something else. So those of you, I really recommend trying again, seeing if you can get onto that stage and experience that.
Yeah, and there's one thing I should tell you also, but the difference between an in-person and a virtual or video or recording is, Dan, when you recall in your video, and it was not obvious when you were doing the in-person presentation, that is, you stumbled a little bit on a word. Remember, there was a little bit of a stumble. In real time, on a stage, everybody ignore it. It's just transparent. You don't hear that. But as soon as you have that same thing on a video, it just seems to jump right out at you. And I think that's the one thing that is all so different between what we're doing here and what an in-person presentation is like, is that when we watch a video or when we look at a screen, we have elevated expectations of perfection in a certain sense. And so some of these little blips and hesitations and so on seem to jump out a little bit more than if we had seen them on a stage.
Right.
There's another question. Will we get any reviews for our talks?
Reviews in the sense of feedback? From the judges? Is it from anybody? Well, let's see. The judges will be asked to speak once we announce the winners, then we'll certainly ask the judges to make a few comments about what they've seen, what they've heard, and their overall comments. I'm always willing to talk one-on-one with anybody who wants some feedback from me personally. But yeah, you'll get some kind of feedback about the event once this is all over, once the judging is done.
Yeah, I definitely think that's something you could message and, ask for if you want specific feedback.
Sure. Yeah. And we can try to pick up on those questions, and maybe one of the judges could answer that. Is that what you think, Dan? Or?
Yeah, I think so. They followed up in the chat in terms of what was good about the presentation, what was missing. So just sort of a review of what to improve on. And I think that's absolutely something we could,
right.
if you follow up with us, we can definitely take a look and let you know.
If I can make a comment sort of in advance of everything, I think the temptation always is there to try to shoehorn as much information into the presentation as possible. And it was one of my biggest struggles in working with the contestants is to try to reduce the size of the script, reduce the length. I kept saying that 3 minutes is not a target, it's the maximum. And by definition of maximum, presentation could be 2 minutes. It could be 1.5 minutes. You could do it in 1 minute. I mean, it takes more skill perhaps to do it in 1 minute or 2 minutes. But to me, if I were to give an overall impression, and I don't know if the judges are going to say this, but it's this terrible temptation of trying to put in too much.
Yeah, no, I agree. I think when I look at these presentations myself, one of the things I look at is how deeply the competitors go into their research, because I think it's a little bit more straightforward to give a sort of overview of the field you're in, right, and relate that to some sort of metaphor and explain that to an audience. But I really do value when I see competitors go into the nitty-gritty of what they're working on, describe the specific features of their work that actually makes it impactful and valuable, and makes it unique, right? You're not just talking about a field of research, you're talking about your very specific contribution and the minor things that you did to make it work. And I think if you can tell that story, and it can be challenging to tell that story in 1 minute, 2 minutes, or 3 minutes, but for what I love to see is when you can tell that story and you can really dive into something that makes me sort of feel like, wow, I actually understand, your paper, right? I understand a little bit of what you specifically have done. I wonder, and I'm curious to see how the judges sort of value this, but I know for me, that's something I really like to look at and see if it's actually included in the presentations. So I don't know, Aline, if you have any key areas that you look for to give you sort of an overall feel of a presentation.
Yeah, no, I wanted also to just first to add to what you were saying right now. It's always tempting for us PhD students to talk about what is unique about our work, because PhD obviously we do novel work. We're unique somehow. We have our own name or brand. So what people need to understand, contestants, is that for judges, usually what matters is how your work, what is the impact? How is it helping? What is the basically, the end result, not how your system works exactly. And this is something we suffer. And whenever we present, we want to tell them how it works, but that's not what matters the most. What matters is that how you're helping, basically. Again, that's my opinion of what judges like or don't like. But again, we never know, right? You never know how they think and what they like the most. But yeah, we're tempted to always explain the system rather than the application.
Yeah. I think that's one of the things we probably contradict each other on, because I really like to see, what exactly is the meat of it. And I think it's sort of easy to give an overview and give an application. It also gives advantages to certain people in certain areas, right? So if you have someone who works in, medicine, and they have really, they can really connect with the audience well, right? Because they're working in an area that's so closely related to a lot of people, right? I had the fortunate advantage of having that, right? Because I'm trying to do medical imaging, right? So I could lean into that. But what I want to, not all of us have this sort of advantage in the sort of application of our research. So I really like to see when people, even if they don't necessarily have like a clear application that they're going towards, they can still teach me something. I can still learn about what their work is and have an understanding of what it's actually doing, right? And yeah, they may not have something flashy, but the fact that they can get that across, because I'm sure we're all doing very technical things, right? So just being able to get that across to me is something I really value a lot. That's something I look for in presentations.
Yeah, look, I agree with you. I personally agree with you, because we need ways to communicate our difficult research and the uniqueness of our research. And I'm not sure if this is what judges, I'm not sure if that's the perspective of the judges, because like my time, for example, the winner was the guy who said, hey, people are thirsty and I'm finding ways to get water to them. He did not really go much into what he's doing. He talked about pipes and water and people being thirsty, and people were like, oh my God, we need to do something about that. So I'm just saying that might be one way. For other people, it might be the way we think. Oh, wow, he found a way to talk about his very difficult deep tech in a very clear manner.
Yeah, no, you're absolutely right. It does come into the end. It does come down to the judges, right? How they're sort of looking at things. So if that's what they value, then that's what you got to try to include in your presentation.
Yeah, and remember, the thing that I always tell contestants to be careful of is to make sure that their metaphors are recognized by the general public or the judges as metaphors and not to be taken literally. So as engineers, we may know when someone is providing us with a metaphor, but that metaphor could be, is that a scientific fact or is that fiction? So I think that's one of the things you have to be careful about. But again, I would tend to think that a judge will look at a particular, will look favorably at a subject when there's something in it for that particular person, when it sort of resonates. On the other hand, if you have a very abstract subject that is, let's say, totally mathematical and may not have an immediate application, the least you can do is to signal your enthusiasm for the subject, why you're so excited about it. Because being excited about something, and if you can convey that excitement to the judge, that also helps. So conveying excitement.
Yeah, no, absolutely. You want to be passionate about your work, right? And it really clearly comes across if you're sort of reciting something, you're not, really enthusiastic. Slight things like that can definitely leave an impression on a judge. So you really need to have that passion for your work and for the presentation itself.
Yeah, I'm assuming we were all waiting, so like, where are you, judges? Come back.
Yeah, the judges, come back, judges.
Obviously a hard decision, right?
Yeah.
Yeah, no, I think to me there are some really, really good presentations, and hard time, very hard time. Yeah, so hopefully we'll meet in person in Denver. That's something we need to look forward to. And hopefully we'll see some of these candidates, coming back again.
Yeah, you should consider it. Everyone should consider it, because virtual is very different than in person. It's not like you're repeating yourself same way. So it's a completely different experience.
Right. Absolutely. The pressure of, standing up in front of people and presenting it versus looking in the screen, having all those eyes on you, it can be a little bit more stressful, I think. So
I don't know if we're encouraging them, Dan, but you guys, I didn't sleep the night before my 3MT.
Okay.
But I encourage you to participate.
It's a good adrenaline rush. If that's if you like that sort of thing, you definitely will remember. You'll remember it. I think I blacked out, honestly, halfway through. I don't remember. I remember walking up on stage. I remember walking off. I actually don't remember much of what happened in between, but apparently I said my speech. So that worked out okay.
Yeah, I remember for me, right before entering the room for the competition, I was really panicking. I came out of the hotel, the conference center. I screamed. That's thankfully for someone who was helping me. He was like, "Introduce yourself, scream." I was like, "Hello, everyone. This is Aline from." I was screaming this outside. People were looking at me, but that really helped me. So I advise you to try that one.
Screaming helped.
I literally screamed. Yeah, it helped.
It helped. Well, you know what I do is I tell contestants to go out into the street, go up and down stairs. They should be able to kind of do their presentation anywhere. And I suggest to them, hold up a cell phone, walk around with this, or do this, and you can be speaking, and people will think you're talking to somebody. So nobody will think you're crazy when you're talking into a cell phone. So you could be practicing your presentation anywhere. But you guys think you were nervous, or Dan, you thought you were nervous in Hawaii. Our competition in Hawaii was on a Monday, and I was already sneaking into the convention center on Friday. I snuck in. It was not officially open, just to check out the venue. So,
and I remember there were some fun.
There were some exciting moments of preparation.
I remember that enormous power bar or sound bar behind
the mixer. The mixer board. The mixer board was slung behind the screen onto a mess of wires, and I believe our technical support was on the floor most of the time, working the mixer board from the floor. So, but it worked,
It worked. Yeah.
It worked.
Very true. See, Amy's rejoined us, so I wonder if the judges have completed their deliberation.
Oh,
can we get a scoop? Imagine.
This is it.
Oh, maybe.
Yeah, Amy's here, so Sherry will be announcing the winners.
Wait for everyone else to roll in here.
Maybe they're all grabbing a coffee or something. Boy, this is a tense moment. Only Amy. We're speechless right now.
Yeah, the drama keeps building, eh?
In drama, I write plays, and silences are supposed to be dramatic. I mean, if you have a silence, the longer you keep that silence, the more you have to deliver when the sound comes back. So if somebody stops speaking for a while, you better have something to deliver at the end of the silence. So if we go silent for the next 2 or 3 or 4 minutes, tension will just rise. What are these guys silent about? Maybe they know something already that we don't. Maybe we've been signaled through a back channel.
True.
Well, we do have something big to deliver, so we can really be silent for 10 minutes.
I know. That's true. No one has trusted us with the results yet, so we can't leak. There's no leaks here. Definitely no leaks. So only Amy's here, which is still a little surprising. Maybe the others are still debating. Yeah, this is quite the moment. Huh. Maybe I don't know what's going on.
So now we have IMS virtual team.
Oh, IMS virtual team, that helps. Oh,
Okay.
That's interesting. Amy has slipped out.
Yeah, I don't think that was Amy,
Yeah.
maybe she joined by mistake because she didn't even speak. So
Yeah,
yeah,
that may have been a mistake.
Okay. So it wasn't Amy. Interesting. Okay.
Well, we continue continue to wait along. Do we have any other
Yeah.
more good
Are
3MT
there
stories?
any questions or anecdotes or anything like this? What, as I say, what drives me in this particular activity, and that kind of makes it enjoyable for me, is when I literally, when I'm working with candidates, I literally see progress minute by minute by minute. And it's one of the few kind of activities where you actually see progress happening in real time. And it's also very nice when a candidate has that aha moment when they finally get the idea of what they're doing, that sort of aha moment of kind of realization of what they didn't think they could do, but even ended up doing.
So Ricardo gave us a nice question. Now that all presentations have rolled for some time, what are the most memorable moments of this event that you have in your mind right now?
Well, you go ahead, Aline. What's your most memorable moment
of this event? I don't know. I think you were just talking about it right now, that like when I was joining the practice, some of the practice meetings, just seeing how a person started, and then when you were telling them, make the end of the words clearer, scream. I think those are the things I'm not going to forget. The way I saw the change in a person, like within a few minutes. I just saw it, really. I saw the presentation went from 5/10 to 8/10, for example. That's for me.
Yeah, I mean, I sort of echo that, right? Like I got a chance to see not everyone's presentations beforehand, but some of them really grow from, having slides that needed quite a few tweaks to having something that, really captivates. I think I really like seeing the creativity that people come with for their slides, the things that they can put together to sort of catch the attention of an audience. To see even just those grow from, the summary slides that I constantly go on about to the very nice slides that we ended up with was really impressive.
Yeah. Yeah, as I say, also it's the process. To me, in a certain sense, it still surprises me in a way that so many of the finalists were actually willing to collaborate with each other, within the groups. I think that bodes very well for the society as a whole, as engineers in our society, that the idea of communicating with the public, or learning how to communicate research and working with each other to improve each other. That to me, that was it's always surprising how cooperative people can be with each other, and that it works. Oh, and the other thing, which again, sort of surprises me also, is one of the reasons for the group meetings is I want to show candidate A that I'm just as hard on candidate B. So I'm not singling out any particular candidate. Say, listen, come to a group meeting where you'll hear I come down hard on this candidate. So it's not just you, I'm not discriminating between candidates in terms of making some suggestions.
I know it's a little bit, it can be a new experience too, getting sort of direct criticism and trying to improve from it. And I think everyone actually that I saw managed it very well. It's not necessarily a fun experience for someone to tell you that, you need to work a lot on something. But kudos to everyone who sort of took that to heart and actually really, really improved their work. I can see it clearly in these presentations. It was really well done. Yeah.
Yeah. So any more? There's another question, I think, unless that was already asked or
I
answered.
think that was already answered.
Nobody wants to compete with Ricardo and give us another question?
Yeah, sure. There must be something like.
Yeah.
Yeah, now we put the responsibility onto the audience now.
The audience. So there are many 3-minute thesis finalists here. You should be able to speak.
Well, it's typing, so this may not be a skill we worked on, right?
Oh, there's the real Amy Hubbard. Oh no, maybe not. Yeah, you know, from my perspective, you know, I learn a lot every year. I learn a little bit more. You know, should you start on a slide first? Should you start on a script first? Should you start on? Oh, there's Sarah.
They're back.
They're back. I can stop. Hi, Sarah. Oh my God, everybody's here.
Are they going to give the results? Okay, I'll call you back.
Very good.
Oh boy, a somber moment. Everyone's been waiting anxiously. Hi, Elizabeth. Back, our MC's back. So Sherry, you can definitely take over.
Okay, sounds good. Well, I want to say thank you to our 3MT competitors. We found it very informative and thought-provoking, all of your presentations as we learned about your research and also your passion for your specific specialization. I always like to see diversity in our competition. We have both male and female participants, as well as academia and industry this year, plus representation that's global, which is delightful to see. Today, we learned about microwaves in the traditional sense of 5G communications and Wi-Fi, but also into new domains such as agricultural and biomedical applications. So without any further delay, I'm going to reveal to you who the judges and the audience have selected for this year's list of awardees. We're going to start off with honorable mention going out to Ajibayo Adeyeye. Let's play microwave pong. Congratulations. We have next up our third place finalist is Ricardo Figueredo. In science we trust, but do scientists trust each other? Congratulations. All right. Second place finalist is Valentina Palazzi. Tireless ears for sensing vibrations. Congratulations. A little silence of applause. And next up, we have the Audience Choice Award. And that came in with one vote difference between his name and the next nearest. And that is Sohail Nori. Let's know our enemies before we fight them. So we thank everybody in the audience who also voted as part of the competition today. And the next up, I'm going to do my my third annual Master of Ceremonies Choice Award, and I'm going to give that out to Yali Zhang, making the connection using nanometer-sized joints. Congratulations, Yali. And John, we need it this year. The drum roll, we always say every year we need it. Drum roll here, please, to our first place winner is Renuka Borathu. Say bye-bye to spotty Wi-Fi. Congratulations to all of our attendees and our competition winners.
Wonderful, that's incredible. Thanks, Sherry. There's been a lot of tension here. The tension mounted. We wondered what was going on with the judges, and they must be having a hard time, and I'm sure they had a hard time. So, you know, thank you so much. This is just incredible. And we've been on a long journey together, the finalists and the committee. So judges, you know, if you care to unmute yourself and say a few words about what you saw, heard, any thoughts about any kind of feedback you'd like to offer? Anybody want to be unmuted? Feel free. Elizabeth, yeah, unmute yourself.
Well, this is my first year participating in the judge, and I had a very hard time with this. There's just so many wonderful research events and thesis and ideas. It's very inspiring. And the other judges who've had other years in it said this was really extraordinary from that point of view. From even last year, I mean, we had a tough time because there was such quality in every direction. So maybe that's why we took long. There's a lot to really parse and sort through. It was very brilliant.
Yeah, thanks, Elizabeth. That's great. Thanks so much for participating. And great. And Sarah, I'm glad that a hurricane didn't throw you off this time. So, Sarah, would you like to say something, or would you like to, or?
Certainly, I'll echo what Sherry mentioned, which is that it's so inspiring to see both the applied and the basic research that's being done by the academic and young professional presenters. When the judges were deliberating, what really sent someone to the top of our list was when they were able to communicate a really balanced perspective on their research and findings, as well as the practical significance of that research to the lay public, which many of us are members of. And then what really put some people over the top was an effective use of their visual, their single static PowerPoint slide. So when that slide was really used to convey some of their research information, that's what kind of set them apart from the rest of the very strong presentations that we saw today. So thank you everyone for your hard work.
Great. Ron, perhaps, would you like to?
Yes, very quickly, I would say again, once again, this was my second opportunity to serve. And as a layperson, I'm just amazed at the caliber of presentation. And I would just say to those who were not necessarily recognized, your contributions were certainly well appreciated. And I hope that the fact that you didn't win any money didn't mean that diminishes your desire to remain engaged as a researcher and following your dreams and goals. So I would just say congratulations to all of you, because in my opinion, all of you are winners. So thank you again for having me. I thoroughly enjoyed this opportunity.
Yeah, thanks so much, Ron. That's great. Amy, what has changed since 2017 for you in this competition?
Well, what has changed, I guess, is the new ideas. So some threads that have still carried through from the initial inaugural 3-minute thesis competition. But what has changed is the caliber of work that's been done to make the effort to communicate their ideas more fully to the audience. And that was clear in every single presentation, that people clearly have practiced and worked hard to think about what sorts of metaphors that they should be using and talking through. And that's not an easy task to do. So that hard work that was done showed in people's presentations, which made it even more challenging for us as judges. So on top of what everyone else has said, the work that they put in really was on full display. And that's what made it a fun, exciting. We had good discussion about what went on, but also what we could see that had happened for all the participants. So we want to congratulate them for putting in that effort, because you have great ideas, you've executed great projects, but if you can't communicate those to other people in various ways, then it only goes to a certain level. But by being able to talk about your research and practicing this, now others have more access to this great work that you're doing. And so that's what really was a pleasure to see and hear today.
Thanks, Amy. So should we ask the winners to if they want to say a few words? Does that make sense? Any of you who have won, please let us know that you're here and raise your hand or something, and we will patch you in to say a
So
few.
Valentina wrote something in the chat. I don't know if they want to say something, please mark it in the chat.
Yeah. Valentina, are you there? Do you want
Ricardo.
Ricardo?
Ricardo, let's unmute him.
Oh, Ricardo? Yes, so Ricardo, so let's see if I can.
I did it already. He
Oh,
can
you
talk.
did it.
Hi,
Okay,
can
there
you
you
hear
are.
me?
Yeah, perfectly. Yes.
Yeah, so I can only thank you a lot. Thanks to the judges for appreciating my talk, and also to the organization, to John, Erin, Daniel, Aline, because those talks really made it. Because my presentation was not that good at the beginning, and I really would like to get more feedback, because the most motivation for me in this contest was really to improve, so not really to win or anything. And I found it a bit difficult in the beginning, because my topic was a bit I thought it was not very relatable, and it gave me a lot of trouble, but I'm really glad that it was recognized, and I can only hope to improve more. So if you can send me some feedback, I'll be more than appreciative of it. So thank you very much, and I hope to see you all next year in person.
Thanks, Ricardo. Wonderful. Thank you. Congratulations. It's a pleasure working with you and with all the other contestants. Anybody else want to say anything? Anyone? Any of the winners? Anyone else?
Hi, this is Valentina.
Oh, hi. Hello.
I don't know if my connection is quite bad, so I'll be very fast. Yes, just want to say thanks for this opportunity, and for mentoring me. I thank the judges, and I thank also the organizers. And as also Ricardo said, it was a great opportunity for growth, and it was good also meeting each other. And I really enjoyed all this journey together. So thank you very much.
Great. Congratulations, Valentina. Nice to see you back again, to see you doing this. Wonderful. Congratulations. Anyone else? Anyone else?
Bio, go ahead. He is raising his hand.
Okay.
Hi. Oh, yeah. I just wanted to echo kind of what Valentina said. Thanks to the organizers for putting this up, all the sessions. I was only able to attend a few of them, but they were very helpful. Thanks to Aline, of course, because I wasn't able to attend some sessions. She took some time to help me out as well. But yeah, it's been a great experience. Hope to be back and better next year. Thank you, guys.
Congratulations. Congratulations. Nice to work with you. Anyone else want to say a few words? If not, maybe Erin, would you like to kind of summarize your thoughts of what you saw today?
Sure, and not just of what I saw today. So I know that Bio had mentioned that he was only able to drop in on, quote, a few of the sessions for the practice for the attendees. To be clear, there were about 30 of these sessions that John conducted, and Dan, Aline, and I would drop in on these sessions. But the contestants worked so hard on their scripts and their slides, and we saw marked improvement on their first drafts. So you contestants know how hard you worked. I think everyone here should know how hard you worked too. And John was behind every one of these sessions. So it's really astonishing to see the improvement, the collective improvement that all of you have shown. And I hope you carry these skills with you for your careers. These will set you apart from your peers. For the rest of this week at the co-located microwave conferences, IMS, RFIC, and ARFTAG, come back and tell us if you see any events that are as engaging as the 3MT, because I think that this is a unique set of people who are presenting at this entire symposium, and that they want you to understand what they're saying. So yeah, I suppose that I would just conclude by saying I enjoyed what I saw today and what I saw for the last 4 months of preparations. And thanks to everybody involved with this.
Great, Erin. So I think we should let that be the last word. It's 2:49 by my clock here. So that's incredibly long. Thank you so much for your patience and your hard work and for being with us and supporting this event. So unless there's something urgent, let's draw this to a close. Thank you. Have a good Sunday, and see you in Denver next year. Okay.
Thank you, everyone.
Bye bye. Bye bye. Bye bye, everyone.
Thank you.
Everybody.
Goodbye.
Bye bye. Bye bye bye.